Hello, we are discussing about GATE 2002 ECE paper and the topic is related to digital circuits. It is required to design a binary modify synchronous counter using AB flip-flops such that the outputs Q2, Q1, Q0 changes as 000, next state is 001, next 010, like this so on. The excitation table for the AB flip-flop is given. And we are going to write down the state table for the modify counter. Next, obtain simplified SOP expressions for the inputs A2, B2, A1, B1, A0, B0 in terms of Q2, Q1, Q0 and their complements. C. Complete the circuit diagram for the modify counter using minimum number of 2 input NAND gates only. You must use only 2 input NAND gates. Okay. So, this is a partial modify circuit diagram. Modify counter partial circuit diagram, and this is a truth table of, that is function table of AB flip-flop, and this is modify counter is nothing but modify up counter. It is starting from 000, 001, 010, 011, 100, and next it will come back to the initial state. Okay, so first we will write the state table and later we will derive the expressions for the A2, B2, A1, B1, A0, B0. Okay, so this is present state. State table implies nothing but which will be consisting of present state which is Q2, Q1 and Q0, and next state implies nothing but again it is Q2 plus Q1 plus Q0 plus. This is present state and next state. Present state, if it is 000, at that time it will going to the 001. If present state is 001, it will be going into 010. If 010 is present state, it will go to 011. If 011 is present state, it will go to 100. If 100 is present state, it will go to the initial state. So that, okay, this will be treated as, this is 000 is one state, 001 is second state, 010 third state, 011 fourth state, 100 fifth state. So this is modify counter. So this is modify counter which is starting from 000 and ending at 100. Whenever it tries to goes to next state from 100, it will go to the initial state as 000. So this is what we can call it as state table. Okay, now we are going to do inputs for the expressions for the inputs, that is nothing but flip-flop inputs. Flip-flop inputs is nothing but we are going in this way. Okay, so first A2, B2 are going to be flip-flop inputs for the B flip-flop, that is Q2 flip-flop, and next A1, B1 are going to be inputs for the Q1 flip-flop. Next A0, B0 are going to be inputs for the Q0 flip-flop. So A2, B2 Q2 flip-flop inputs, A1, B1 Q1 flip-flop inputs, A0, B0 Q0 flip-flop inputs. So we are going to express A2, B2, A1, B1, A0, B0 in terms of Q2, Q1, Q0. Okay, so before going to do this one, we require an excitation table. Even though the given thing is given that one AB functional table, okay, we are going to get excitation table from this one. Okay, this is excitation table. Excitation table implies nothing but if you want to get desired next state from known present state, what must be the inputs you should apply. Okay, you know the present state and you want to go for a desired next state. Okay, your own desired next state. By that time, what input combination should give the transition, that is what excitation table. So excitation table of AB flip-flop given is going to be looks like this one. Qn is going to be known state and we want to go for the Qn plus 1. So if it is the desired transition, by that time what should be the values of A and B? What should be the values of A and B? This is what excitation table. So if you want to get the desired transition from present state to next state, this is Qn plus 1. Okay, so this is present state and it is next state. If you want to get the desired transition, what must be the values you should apply? A, B. So let us assume present state is 0 and you want to move it to 0. So what must be the input combination? If you want to go for 0 0 at that time, okay, 0 is going to be your next state. From this table you can say that one irrespective of present state you can go for the 0 state if you give AB as 1 1. So you can think in this way. So if you are going for 0 to 0 transition, at that time AB can be in this way. AB will go like this. Okay, AB can be, you can give either 0 1 1, because if you give 1 1 at that time irrespective of present state you can go for the 0 state. Otherwise if you know the present state you can be in the same state by using 1 0. If you give 1 0 from this table, okay, 1 0 is nothing but next state is same as present state. So present state you know it as 0, so you can keep the same present state as next state. By that time 1 0 is required, so instead of this one you can make it as 1x. So instead of these two combinations you can write it as 1x. Okay, similarly 0 to 1 transition if you want to get, at that time 0 to 1 implies nothing but complement. So next state is complement of present state. Complement you will get whenever you give 0 1. So AB can be 0 1. Otherwise irrespective of present state you can go to the next state as 1 by using 0 0. Okay, so in this case instead of this one A must be 0 and B can be anything, so you can give this combination. In case of 1 0, 1 to 0, 1 to 0 is nothing but again it is complement. Complement you will get 1 for the 0 1, and irrespective of present state if you want to go for 0 you must give 1 1. Instead of this one you can apply x 1. Next 1 1 transition, present state is 1, you want to go for the next state as also 1. By that time, okay, same state, next state is same as present state, that is nothing but 1 0 combination. Irrespective of present state you can go for the 1 state by applying 0 0. So this implies nothing but x 0. So this is what excitation table 0 0 is nothing but 1x. Okay, 0 1 implies nothing but 0x, 1 0 is x1, 1 1 is nothing but 0x x0 this is. So by using this one you can directly fill this one. If you want to write it for the A2 B2 you must only check the Q2 and Q2 plus, because A2 B2 are going to be inputs of Q2 flip flop. So only you must check what is the present state of Q2, what will be the next state of Q2, so that Q2 Q2 plus columns only you have to check. So from that one you can see the transition, it is 0 0 transition. 0 0 transition is nothing but 1x. Next 0 0 transition 1x, 0 0 transition 1x, 0 1 is nothing but 0x, 1 0 is nothing but x1. So this is what A2 B2 you can write. Next A1 B1, A1 B1 is nothing but you must check only Q1 and Q1 plus, because A1 B1 are inputs of Q1 flip flop, so that you should check only Q1 Q1 plus. So Q1 Q1 plus only you are checking. So 0 to 0 transition, 0 to 0 transition is 1x. Next 0 1 transition, that is 0x. Next 1 1 transition, 1 1 is nothing but x0. Next 1 0 transition is x1. Next 0 0 transition, that is 1x. So this is what you are getting it for the A1 B1. Similarly you can get it for the A0 B0. A0 B0 is nothing but you must check Q0 Q0 plus. Okay, Q0 Q0 plus 0 to 1 transition, that is 0x inputs. Next 1 to 0 transition x1. Next 0 to 1 transition 0x, 1 to 0 transition x1. Okay, next last one is nothing but 0 to 0 transition. 0 to 0 transition is nothing but 1x. So like this you are writing. So this is 0 to 0 transition, last one 0 to 0 transition, that is 1x, and 1 to 0 transition, that is x1, and 1 to 0, next 1 to 1 transition, 1 to 1 transition, sorry, 0 to 1 transition, 0 to 1 transition, that is 0x, and 1 to 0 x1, next 0 to 1, that is 0x. So these are going to be a2, b2, a1, b1, a0, b0, and make it as m0, m1, m2, m3, m4. These are the minterms, and don't cares, that is nothing but which are not used, that will be treated as don't cares. Don't care minterms are going to be m5, m6, and m7. These are going to be the don't cares. So you can write a1 is going to be function of, okay, q2, q1, q0, that is sigma m of. So first we will start with a2. a2 is equal to function of q2, q1, q0. a2 is going to be 1 for m0, m1, and m2 plus don't cares of 4, 5, 6, 7. Next b2 is going to be function of, b2 is function of again q2, q1, and q0, that you can write it as sigma m of, okay. b2 is only for m4, and all others are going to be don't cares, that is nothing but 0, 1, 2, 3, 5, 6, 7, all are going to be don't cares. So next a1 is equal to function of q2, q1, q0, sigma m of a1 is nothing but this is 0th minterm and 4th minterm, 0th minterm, 4th minterm for a1 plus don't cares of a1 is nothing but 2, 3 are going to be don't cares along with 5, 6, 7. And next b1, b1 is function of again q2, q1, q0, all are going to be function of these three things only. Sigma m of b1 is only consisting of m3, that is 3 minterm, plus don't cares of 0, 1, 4, 5, 6, 7. Next a0 is going to be, I am writing directly, sigma m of a0 is nothing but only 4th one plus, okay, a0 only 4th one plus don't cares of 1, 3, 5, 6, 7. And b0 is sigma m of 1, 3 plus don't cares of 0, 2, 4, 5, 6, 7. Okay, so these are going to be the, these are a0, b1, that is functions of a2, b2, a1, b1, a0, b0. These are functions of these things. Next you can minimize this one, okay. As you are minimizing this, you will get the functions in this way. So these things I am going with, and it is b0. Here I can write it as b0. So a2 can be, if you are going with a k map like this, so k map, that is 3 variable k map you can go with, okay. So a2, a1, a0, for all these things you have to draw a 3 variable k map, and you are going to minimize that one, okay. So a2 is going to be, this is for a2, a2 implies nothing but here q2, q1, q0. So by that time a2 consisting of 0, 1, 2 terms, this is 0 and it is 1, this is 0, 0, 0, 1, 1, 1, 1, 0. So 0, 1, 2, and don't cares are nothing but 4, 5, don't cares are 4, 5, 6, 7. 4 5 6 7 are going to be don't only 5 6 7 4 5 6 7 are don't cares. So by this time you can go in this way, these two are going to be combined to get one term, that is nothing but q1 bar. Okay, and these two can be combined, that one and this one can be combined, so that what you are getting is 0 0, that is q naught bar. So a2 is equal to q1 bar plus q naught bar. This is what you can get. Okay, otherwise q1 q naught bar also you can write. So this is a2. And next similarly you can find it for the b2 if you are going with at that time. For b2 this is the k map for b2. This is q2 q1 q naught. b2 is nothing but 4 is nothing but this one 0 1 0 0 0 1 1 1 1 0. So 4 only, and 0 1 2 3 all are going to be, the all others are going to be same, don't cares. So that this will be treated as, you no need to go for the k map, directly you can write it as b2 is equal to 1. So a2 is equal to q1 plus q naught bar, b2 is equal to 1, and a1, for a1 you can write, a1 can be written, this is what a1. Okay, for a1 is nothing but 0 comma 4 are ones, so these are the ones. And next 2 3 5 6 7, this is 2 3 5 6 7 are don't case 2 3, and it is 5 6 7. So these two things and these two things can be combined, and so that what you are getting is nothing but this is q naught bar you will get. So for this one it is q naught bar, so it is a1 is equal to q naught bar. Similarly b1 you can go with b1 is nothing but this one b1. Okay, b1 is consisting of only 3 is nothing but this one, and all others are going to be 0 1 4 0 1 4 5 6 7. So these four can be combined, so that you are getting it as these four, if you combine you will get it as q naught. So b1 is equal to q naught, and a1 is equal to q naught bar. And next a naught, if you go with, this is for a naught. a naught consisting of only 4 is nothing but this one, and 1 3 5 7, this is 1, and it is 3 5 6 7 5 6 7. So in this one only two things can be combined, this one, and by that time a naught can be written as, okay, this is q2, and it is 0 0 0 1, that is nothing but q2 multiplied by q1 bar. This is what you will get. a naught is equal to q2 q1 bar you will get. And similarly if you are going for the last one, b naught is equal to this is b naught. Okay, for b naught 1 and 3, this is 1 and it is 3, both are ones, and 0 is don't care, 2 is don't care, and 5 6 7 are going to be don't cares. 5 6 7 are don't cares, so that you can only go with this one. So this one implies nothing but simply this is either you can go anyway. Okay, so that I am going in this way, this is nothing but q2 bar. So b naught is equal to q2 bar. So what you are going to get is nothing but, first of all you are writing a2 is equal to q1 bar plus q naught bar. Next b2 is equal to 1, and a1 is equal to q naught bar, b1 is q naught, and a naught is equal to q2 q1 bar, and b naught is equal to q2 bar. Okay, now I will write these expressions and I will try to simplify, to complete the circuit diagram. Okay, So this is, and what we know the equations is nothing but A2 is equal to Q1 bar plus Q naught bar, and B2 is equal to 1, A1 is equal to Q naught bar, and B1 is equal to Q naught, A naught is equal to Q2 Q1 bar, and B naught is equal to Q2 bar. So complete this circuit diagram. A2 will be Q1 bar plus Q naught bar. So make an OR gate. Okay, make an OR gate with Q2 bar, Q naught bar, and Q1 bar. That is nothing but you are taking Q naught bar and Q1 bar. That is nothing but from here you are taking the lines that I am not writing. It will become zigzag, so that the output of that one is going to be connected as A2. Okay, next B2 is 1, so that connected to 1. B2 is equal to 1. Next A1 is Q naught bar. A1 is Q naught bar is nothing but this one. A1 is going to be connected as Q naught bar. Next B1 is Q naught. So B1 is Q naught. That is nothing but like this. B1 is Q naught. Next A naught. A naught is equal to Q2 Q1 bar. So A naught is equal to, we are going with a AND gate with that one two inputs. One is nothing but Q2 Q1 bar. Q2 is nothing but one input. I am connecting over here, and Q1 bar is nothing but like this you are taking. So this is Q2 Q1 bar, which is nothing but A naught. It will be connected to A naught, and B naught is equal to Q2 bar. So you are taking it directly and you are connecting it over here. So this is a complete circuit diagram. Okay, now this is going to be acting as modify synchronous counter. Modify synchronous counter. Thank you.